Good day, everyone. I'm Anne Baez, and today I am going to introduce my embedded system made using DE10 standard board. With a strong belief in the importance of preparedness, especially in emergencies, I developed a security system. I took inspiration from existing system designs, modifying and refining them to suit specific needs. Additionally, I also considered the challenge of redesigning the system, showcasing not only the content but also the ability to create a tailored solution. This project represents a blend of knowledge and practical application, resulting in an innovative security solution. So, these are the various aspects that I'll be explaining throughout my presentation. So we know that the technological world is rapidly evolving, so the security system represents an innovative solution for ensuring safety. Built on the powerful Intel system on chip FPGA, this system integrates advanced hardware and software, featuring components such as the NIAS 2 processor, hex displays, switches, keys, and LEDs. It established an adaptable security paradigm through the platform designer. The system offers distinct control modes, which are default system, surveillance mode, lockdown mode, and panic mode, addressing contemporary security challenges. So, for the objectives of this project system, I specifically want to investigate the implement and seamless integration of hardware and software components. So, it includes the code and RDE10 standard port. Then, next is I want to analyze and implement controls for diverse security scenarios. That's why I incorporated the modes for security. And lastly, I want to prioritize discrete surveillance features through comprehensive research. Now, let's move on to the hardware setup. So, the security system is an embedded system, which is processed by the Intel System on Chip FPGA module, which seamlessly connect with a dual-core processor, establishing a dynamic foundation for our security solution. So, we learn to utilize components such as the NIAS 2 processor, on-chip memory, PLL, SD-RAM, switches, timers, LEDs, hex displays, and control registers. So we covered these components thoroughly in our coursework and applied them in various homework labs, enabling us to create a tailored and responsive configuration. And now I am using them for my security responses. Now, here is my platform designer, which has the key components for efficient data exchange and control signals. Let's start with the NIAS 2 processor. So this is the brain of our system, which manages the instruction, data processing, debugging, and interruption. Here we also have our on-chip memory, which is an access memory bank that ensures fast storage and retrieval of data for critical system operation. We also have here our SD-RAM, or the Synchronous Dynamic Random Access Memory, which is a substantial and versatile memory solution for storing and retrieving crucial data. Of course, we also have the JTAG UART, or the Joint Test Action Group, which enables efficient debugging and communication during the system development. We also have our timers, which is crucial for time-sensitive operations, including the countdown and time-based surveillance mode. Then we have our hex and LEDs, which serve as visual indicators for conveying critical information, alarms, or system statuses for users. Then here, we have our PLL, or the phase lock loop, which maintain a stable and synchronized clock throughout the system. So it also prevents the timing issues. Then we have our switches, which serve as physical sensors that detect changes in the environment, providing valuable inputs to our security system. And lastly, we have our custom computational component that enhances the system capabilities, potentially contributing to specific operations or custom algorithms. So for my module, I have the security system SD-RAM. This is crucial for bridging the hardware and software components. It interfaces with the main system module, managing signals and peripherals. So we have here the clocks, memory-related signals, hex displays, key, and switch inputs. We also have the LED outputs to facilitate information exchange, ensuring the flow of integration. So this is really important so that the connection with our hardware or the DE10 standard board and the codes can flow directly to the system. So for the application of the system, let's start first with our hex interface. So the hex interface acts as the informative dashboard presenting critical information such as the countdown, arm states, and emergency messages. It offers users a visual representation of system status, ensuring an immediate awareness. Here we also have our LED visual alarm, which captures the attention during the security breaches. It dynamically displays serves as a visual alert, significantly boosting the system effectiveness in responding to security events. We have here our key for arming and disarming, our user-friendly key provided commands for arming the system. This feature ensures users can easily control and manage the security state according to their needs, enhancing the overall user experiences. We have here our switch as a sensor, which mimics the world sensors like the door, window sensors. We also have the motion detectors, right? And this switches acts as effective input for surveillance. So we detected the changes in the physical environment, offering the crucial information for the system to respond appropriately. So here we also have our switch 8 and 9, which are the control mode of the system, which offers the adaptability to have diverse security needs. So in this control mode, I created three controls, and we also have the default system. So we have the control 1 as surveillance mode, control 2 as lockdown mode, and when both switches or both controls are on, we can have our panic mode. So these are the system features. First, we have our display countdown function. So the display countdown function shows the hex display, creating a visual countdown during arming or disarming operation. It counts down from A, which is a transition of disarming the armed system, to 0. So it will show A, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So from armed to 0, it means that from armed system to disarming the system. So it's all about the boosting user awareness and ensuring an immediate action to the triggered sensors. Here we also have our blink LEDs function. So this dynamically manages the LED array, serving as a visual alert system. It's a feature that grab attention, providing a clear visual signal in response to security events. We have here our ARM system function. So the ARM system function is a system initiation for arming the system. It involves displaying DEF in static motion on the hex interface and sending a system arm message to the console, making sure users get a clear indication that the system is protected. Here we have our surveillance mode function. It is tailored for discrete monitoring. The surveillance mode function continuously checks sensor state. If the sensors are triggered, it initiates the countdown function, which starts from A going down to 0, as mentioned earlier. At the end of the countdown, it will light the LED display, which serve as alarms. The value of the LED is equal to the triggered sensor. Together with that, the hex display DEF or the fend system is shown. These are vital features for scenarios requiring careful attention. So here we have our panic mode function. So for emergency situations, it cycles through a moving DEF messages on the hex display and alternates LED states. It also shows Alert Defend the Security System Now message to the console. This response creates a sense of urgency and ensuring immediate attention action during the crisis. Last, we have our lockdown mode function. It boosts the system security posture. The lockdown mode function implements also a count from arm to 0. The LED goes blinking in this state. It promptly triggers an alarm, giving users a brief window to disarm the system before escalating a full lockdown. But when a full lockdown is initiated, it will send a message to the console. The system is in lockdown mode. Authorities have been alerted and is enrolled. So those are the features of the security system. So now let's dive into the operation mode. Here is our default mode. So the default mode displays DEF when armed, reassuring users of monitoring and protection. DEF means defend, and since it's in static motion or it's not moving at all, it means that the system is armed. And this one is our control one or the surveillance mode. It enables discrete monitoring, starting a countdown if triggered, and it is ideal for situation prioritizing observation. So now let's see how it works. So when you open the control one, it will detect if a sensor is triggered. As of now, there is no sensor that has been triggered. Now you will see that it is starting to count down. Since we have our sensor that has been triggered, the system will count from A to 0. A means armed. Armed going to the state of being disarmed. You can also see that when the sensor has been triggered and also turned off, you can see that the sensor or the hex is also repeating counting down. Here you can see that the number of the sensors that has been turned on or has been triggered is also the value of the LED or the alarm in the system. Here we have 28 sensors that has been triggered. You can see that the alarm also has the equal value as our sensor, so it's also 28. So the system will be armed after that, and it will also still detect it if there are sensor that is triggered or it's already turned off. So when the sensor is turned off, the countdown will stop and the security system will be armed. Now here is our control 2 or our lockdown mode. So this lockdown mode implements a countdown mechanism triggering an immediate alarm upon any sensor breach, ensuring heightened security. So let's see how it works. So from A again means armed to going to 0. It has a blinking alarm system so that everyone will know that there is something going on. And at the end of it, at the end of the lockdown mode, it will show the system is now in lockdown mode. Authorities have been alerted and is en route if the system has been full lockdown. But if you triggered or if you arm the system using the key 0, it will arm the system and it will stop the full lockdown. And lastly, we have our panic mode. So the panic mode displays a dynamic DEF motion, providing an immediate response to emergency. It also say an alert defend the security system now. This one is presented in our console. So if the user or the protector, or maybe we can say the guard or security officer, they will be notified that you should defend the security system now. This one is very important when there's an emergency. So in summary, the security system using the E10 standard board represents a fusion of advanced hardware and software. It redefines security with features like display countdown, blink LEDs, arm system, surveillance mode, panic mode, and lockdown mode. So the smooth integration of hardware components made with the platform designer demonstrate a blend of innovation and practicality, effectively tackling modern security challenges. So this system signifies a significant step forward in creating user-friendly and responsive solutions for today's dynamic security requirements. And that's all. Thank you. So all the files and links will be provided in the description down below.